Cool. So Tony gets to talk up WebVR and all the amazing things that it hopefully will do for everybody. And then I think we're going to have some really awesome showcases of some of the things that people are actually doing with it tonight. And that leaves me in the middle to give the really boring technical talk where I talk really fast about APIs that most people will never touch. But that's what I'm here for. So by way of introduction, although Tony already kind of went over it, my name is Brandon Jones. I work on the Google Chrome team, and I was, along with Vlad, one of the creators of the WebVR API about 3 years back now, which is a little bit of a shock to hear it coming out of Tony. And yeah, I'm still functioning as a WebVR spec editor today. I'm actually doing more spec work than engineering at this point. Which is a little sad for me. But in any case, yeah, I want to talk about where the API itself is actually going to be going over the next little bit. The state of the art, Tony covered pretty well. We're at what we call version 1.1, which is a completely meaningless number. It's just something that the implementers use to disambiguate from the various different iterations that we've had that go through here. And it generally works pretty well. You can do some cool stuff with it. It requires a little bit of hoop jumping, but you can put together some nice content with it, but we've discovered over the time that it has some kind of sticky edge cases to it. One of the biggest ones that's come up recently is we had a whole bunch of the platform leads for the various browsers, the people who try to steer the overall direction of the web come up and say, this is really cool, and it's completely breaking web conventions here, 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 and here. So let's change all those things and then you're good. And we're like, yeah, but we kind of wanted to ship in like, a few months, but okay. And it was actually really good advice that they gave us, so we didn't want to just toss it out. And so it's one of the reasons that we kicked off this next iteration of the API, which we're calling WebVR 2.0. Once again, completely meaningless number. It actually is never going to show up in the browser as a 2.0 product. It's just something that we used to discuss it internally. This is a version that nobody can actually use yet. We're still going through the actual spec work for figuring out exactly how the features should work, and we're being much more rigorous about it this time, because part of the problem that we had with the initial version is that there was a couple of cases where we'd look at these silly little edge cases of, oh, well, what if the browser gets into this state, and how do we handle it? And everybody kind of had different answers. And so you get these minor little inconsistencies, and inconsistencies are terrible for the web. We all know this. It's like, trying to get that CSS line to go just pixel perfect, and you get it working in Chrome and Safari and Edge, and then Mozilla is just like, nope, screw you. Not picking on Mozilla. We all do it in some aspect. But in any case, we're trying to get rid of that as much as possible as we can with WebVR 2.0. It currently exists as an explainer doc, and the unfortunate part of all of this is that it's definitely not going to be anywhere near backwards compatible with what we've got right now. Although the broad, the broad concepts that people have put together for WebVR 1.1 content will still continue over. You'll just have to port the code at some point. Let's think. And yes, I should mention that I'm going to talk about some of the things that we're hoping to put into that, but nothing has actually been finalized yet, so you may get some syntax changes from what we're going to go over here. So to actually throw up some code on here, which might be the first and last time tonight, I wanted to show off some of the differences between where we're at now and where we're hoping to be. As you can see, like I've highlighted in different colors the various aligning bits of the spec, and so you can compare what the syntax changes are. It's not that different. Like, of course, this is a very trimmed down chunk of code. It would never do anything useful on its own. But the idea of getting the VR devices is there, starting, presenting, setting layers, doing the animation loop, all that. And you can see that broadly it's the same thing, and you can kind of draw a one-to-one comparison for it. We're just trying to do things in a much more rigorous, much more predictable way that gives developers a lot more control over what the browser is actually doing. And I'll go over a few of those items right now. So in VR 1.1, WebVR 1.1, we had the single object called VR display. And then this is what everything spawned off of. This is what did all of your, like, I want to know which direction the headset's looking, and I want to send imagery to it, and all this stuff. And this worked out pretty well, but one of the big problems with it is that the moment you got one of those, the system had to spin up tracking because it never knew exactly when you'd start asking for pose data. The practical side effect of this is if you're, say, CNN.com and you want to add a VR feature and you're going to have some video that's like way down below the fold that happens to be panoramic and you want to spin up WebVR for it, you want to say, hey, I want to ask and see if the feature is there. And we're going to say, yes, it is. And as a side effect, the Oculus window just popped up. And nobody knows why, because the content's way down there and it's a terrible user experience. So to solve that, we're breaking this monolithic object up into what we call now the VR device and the VR session. The device is just a really high-level explanation of this is a piece of hardware, and it's generally got this name. And a couple of other really basic things about it that don't require you to spin up any of the tracking or anything like that. And then the VR session, which is something that you have to explicitly create, or request in this case, because we can't deny it, is what you do all of your actual presentation and motion monitoring off of. And you can control the lifetime of that object very, very tightly so that you can put the VR button on your page and say, click here for VR, but nothing actually starts tracking until you as the page author make a conscious decision to do so. This ties into allowing us to have what we call a better magic window experience. Now, magic window is kind of a fuzzy term, but in most cases it means that, like, if I've got my phone out and I'm looking at the page, I can do this, and if I'm looking at a panorama, it'll actually track. And this is something that we've seen on YouTube or various different panoramic photos where this is a really simple way of, one, getting an idea that there's more content to see. You can kind of see it wiggling around on your phone. And two, just having a really simple, like, I'm sitting on the bus and I don't want to strap this thing on because my bag will get stolen. And so I'm just going to look around like this and get an idea of what the content is. It's not as impactful as the full VR experience, but it kind of hints that there's more to see. We wanted to make this an actual feature, not just kind of a weird side effect like it is in the existing VR. So we're giving people a way to request what we call a non-exclusive session. And this just says, well, I can go and monitor the movement of the VR device, whether it be my phone or maybe an Oculus Rift or something, but I can't actually push imagery to it. I can't lock other people out of it. It's just something I'm passively observing, and that has some different parameters to it, or some different behavior to it than normal. Let's see. Then rendering quality. This is something that we've heard quite a bit about, actually, for different use cases. When you're rendering to VR, in case you're not familiar with the idea, you actually tend to render a buffer that's much larger than the physical screen display. And this is because there's going to be some post-process distortion that's happening that makes it match the optics of the lens. Because of this, if you want to get like a perfect 1-to-1 pixel ratio match at the very center of your vision, you end up rendering a really big buffer. This is not so much an issue on desktop where you have your nice beefy NVIDIA cards backing your Vive or Rift, but on mobile, you usually just can't do that and still maintain a respectable frame rate. So with WebVR 1.1, we would always kind of err on the side of, well, you probably want performance over quality. And so we'd report this much lower resolution canvas that you should be creating. We only ever reported one number. We've heard from several people that this is not a good trade-off. They want to be able to say, well, hey, I don't have high-performing content, but I do have a lot of text, or I have very high-quality imagery that I want to get across. Tell me exactly what numbers I should use to make that as high quality as possible. So this is one of the things that we're doing, is you can choose to, do I want Doom or do I want Doom? And the API can actually report that back to you now. This is a point of confusion for a lot of people, but it's something that I think will be increasingly valuable as the VR ecosystem evolves. We're introducing a concept of what's called a frame of reference. And this is basically saying, this is the coordinate system that I want all the pose data, all the matrices to come back in. So if you're familiar with VR concepts, especially on the desktop, you're already familiar with a couple of these. We have what we call the eye level. This is what WebVR calls it at the moment. The eye level frame of reference, which is if I'm moving around, and of course this isn't positional tracking, but if I'm moving around like this, everything is relative to that first point that I initially got a reading from. So this is really good if you're just sitting in a chair and I want to nod my head side to side and just look around, and it gives you good readings. But if you want to do something that's commonly called room scale, where I actually want to get up and move around my room and have some idea of where my boundaries are, what you really want at that point is for your coordinate system to place the floor at like 0. So that in your virtual world, you can render the floor at 0 as well, and you know that they're going to line up. If I look down, it feels like I'm actually walking on the floor. But something like Daydream just simply does not support that. It doesn't have enough information about the environment around it. So you could do this with WebVR, but it was a hot mess. You would go and get the pose, and then you would ask to see if there are stage parameters, which told you that we were dealing with a room scale thing, and then you would do lots and lots of matrix math and hope that you did it in the right order, and find out 3 months later that you actually didn't, and now if somebody does this, then their IPD gets switched, and it's terrible. So now we just have you say, pass it in when you get the device and say, I want these at eye level. I want these in the room scale, the stage. Or we have one that's called a head model, which is explicitly taking, even if you have a Rift, you explicitly just do the 3DOF. And this is useful if you're doing, say, a 360 photo or video or something. And it can actually save on battery too, which is why we're explicitly introducing that. There's also a bunch of things that we're just getting rid of because we found over time as people were developing with them, they either weren't useful, weren't supportable the way that we thought, or just didn't seem to have any, nobody was interested in actually carrying it through. So something like resetting the pose. This is the ability to say, okay, I'm facing this way and my forward vector is that way. I'm going to hit some button or do something in the thing and reset it so that my forward vector is the way that I'm currently facing. This is something that most of the APIs support, but it's done in such a way that if we actually supported it on the web, you would make that reset and it would actually affect all your other tabs as well, unless we were going through a lot of work to make it not do that, which is bad. And it turns out that most of the APIs have, or most of the devices have some better way of doing that. Like on Daydream, you just hold down a button and it resets for you. So this didn't really need to be part of the API. It goes. Is connected goes because we have events for that. Has orientation. What sort of useless VR device does not give you at least orientation? It's gone. All these got different types of things. The field of view and offset, those are represented by matrices now. So lots of cruft that we're taking out of the API to make it slimmer and easier to support. I have no idea how much time I have left. I am just about out of time. So let's skim through this really, really fast. That's all the stuff that we want to introduce in 2.0. Then beyond that, we get into more speculative territory. Some of this may never materialize, but it's what we're talking about. We have a layering system, which is a lot like Photoshop layers, where you can just stack imagery on top of each other. It's useful for things like videos or gaze cursors. We want to introduce a bunch of these because we think they can be really useful. It's something that the native APIs do pretty well. We want to allow for things like gaze cursors and just taking like a normal HTML image and say, just stick that in VR for me. And I shouldn't even have to pump the render loop at that point. That would be really cool. This might also be the way that we get DRM videos in there because that's currently a problem rendering everything out to WebGL. We want to bring more of the DOM over into WebVR because right now there's this huge gulf between DOM content and GL content, and never the twain shall meet as far as we can tell. But we want to be able to bring over, like, maybe say capture an iframe and use that as a texture in our WebGL scene. Or going the other way, maybe if we're looking at a page in VR like in a normal browser. We want to find ways to punch parts of the page out, probably using CSS or something like that. Lots of conversations going on here. We still don't know exactly what form it's going to take, but it's something that's generated a lot of intense interest from both users and implementers alike. We're talking a lot about doing an explicit VR input API. Now, at the moment, we do everything through Gamepad, and it kind of works. You can cobble something together with that, but it's a very blunt stick for a very complex problem. And so we want to have something that abstracts away a lot more of these things and gives you a reasonable input system that scales all the way from like tapping on the side of my head with Gear VR to Oculus Touch to the Daydream controller and everything in between. Potentially even for devices that we haven't seen on the market yet, that we don't know about. This is going to be akin to trying to take mouse and keyboard, or well, mouse and touch and stylus input and boiling them all down into the pointer API. It's going to be hard, but it's something that we feel is very necessary to tackle. And then we also want to tackle things like with HoloLens or Tango. They have the ability to not to just be stuck in that room scale environment, but go walking around in the entire building, the entire world for all we know, and it's constantly pulling in new tracking information. We want to be able to support that going forward, and that requires a lot of new concepts around how you track things. You can't just say, well, I started here, that's 0, 0, 0. I'm going to walk a mile that way, and I want to stay in this exact same coordinate system. Floating point breaks down at some point. You just can't do that. So we're baking some of the right hooks into the API to allow for that in the future. And that is everything that I have right now. Hopefully I didn't talk too fast. Can I play a video? Cool.